Properties of numbers. Properties of numbers, or number properties, we say either way, are used to help solve mathematical problems, most especially in our upper level math classes that you'll take in middle school and high school. You've learned some of these number properties beginning in kindergarten, and you've learned a few along the way, and now we're going to review and use several of them this school year and adding a few more. Next year you'll have a few more added to the ones that I'm going to teach you and we're going to review this year. So let's start with our first number property, which is the commutative property of addition. The commutative property of addition is when numbers can be added in any order, the sum will always stay the same. If we look at the word commutative, we see the word commute in it, and commute means to drive back and forth. So if you commuted from your home to school, whether you drove or you were on a bus, you go the same route to school, and you would take the same route going back home from school to home in the afternoon. You're going to the same way, your distance did not change. The commutative property of addition are your basic math facts that you started learning in kindergarten and worked on in first and second grade. So you learned how to add 7 plus 2 equals 9, and no matter if you said 2 plus 7 in a different order, you still got 9 as your answer. The sum did not change. The commutative property of multiplication is just like the commutative property of addition, except you're multiplying numbers. These are numbers that can be multiplied in any order. Your product will be the same. These are our basic multiplication facts. 5 times 4 equals 20, and if you flip the numbers and start with 4 instead, 4 times 5 is 20. You still get the same product. There is no commutative property for subtraction or division. Our next property is associative property of addition, and you will have a group of numbers being added, and no matter how you group these numbers, as long as all the numbers are being added, your sum will stay the same. So numbers are being associated together in groups. In our example here, we're adding 8, 5, and 2 together, and we grouped 8 and 5 together and added those to get 13. Once we had 13, then we added 2, we got 15. Then we took the numbers again, and this time we did a different grouping, and we grouped 5 plus 2 first, and that gave us 7, and added that to 8, and you still got 15. If we grouped 8 and 2 together, we would get 10, and if we had 5 to it, we would end up with 15. That is the associative property of addition. Our associative property of multiplication is the grouping of numbers being multiplied does not matter. The product will still be the same. So if you are multiplying all these numbers together and group whichever 2 or 3 numbers together that you want to group and multiply them, you'll still end up with the same product. So in the example here, we're multiplying 2 and 3 and 7 together. So we grouped 2 and 3 together and we got 6, and we multiply the 6 by that 7 and you end up with 42. The next time around, we grouped 3 and 7 together first and multiplied those to get 21, and then took 21 and multiplied by 2, and we end up with 42. Same product. If we put and grouped 2 and 7 together, that would give us 14, and then take 14 and multiply by that leftover add-on our multiplier of 3, we would end up with 42 as well. So no matter the grouping of the numbers being multiplied, your product will still stay the same. So the associative property works with addition and multiplication, but there is no associative property for subtraction or division. The identity property of addition. In the identity property of addition, if 0 is added to any number, the sum will be that number. 0 is what we call our identity element for addition. Let's think of an example. You take yourself and you add nothing to yourself, you're still going to be yourself looking exactly like you see yourself in a mirror. So if you've added something to you, if you've added nothing to you, you're still yourself, your own identity. You are who you are. So with our example here, we had 712, we added 0 to it, we still got 712. It did not change. The 0 did not change it at all. And that is our identity property of addition. Our identity property of multiplication is a bit different in the fact that our identity element for multiplication is 1. So if you take yourself and multiply yourself only once, you're still going to end up with just yourself. It's not as if you multiplied and became 2 or 3 or 4 or 5 or a zillion people, zillion of yourself. You are still yourself. So if 1 is multiplied by any number, the product will be that number. So in our example, 58 times 1, we multiply 58 times 1, we end up with 58. It did not change. So that is the identity property of multiplication. There are no identity properties for subtraction or division. Next is our inverse property of addition. The sum of a number and its opposite is 0. And we'll do this when we're learning integers, which I believe begins in 6th grade. Used to be 5th grade, but in this case we may use it a little bit this year, gaining more knowledge. So if you took a number such as 7 and you added it to its opposite is -7, they cancel each other out and they become 0. So it's like you go up 7 and then you add it to a -7 going backwards and you end up at 0. Opposite in mathematics is called a reciprocal. And we're going to be using reciprocals when we learn how to divide fractions. That takes us to our inverse property of multiplication, and that's when we are going to use this property when we're dividing by fractions, which we'll do later in the year. The inverse property of multiplication is when we have the product of a number and its reciprocal is 1. So you take your example 1/2, your fraction 1/2, multiply it by its reciprocal, and reciprocal is just taking a number and flipping it over. So in the case of 1/2, if we flipped it over, 2 becomes our numerator and 1 becomes our denominator. So then 1/2 times 2 over 1 is 1. Or if we took the whole number 2 and multiplied by 1/2, if you have 2 and take half of it, you're going to end up with 1. So this is our inverse property of multiplication. The last property we're going to work with this year is the distributive property. If a factor is multiplied by the sum of 2 numbers, you can multiply each of the 2 numbers by the factor and then add. So here is like you have A times the quantity B plus C. So you're distributing the A to the B and then you're distributing it to the C. So then it becomes A times B, right here, added to A times C. In our example here, we have 2 times the quantity 3 plus 4. Anything in parentheses is called a quantity. So we're going to distribute the 2 to the 3 to get 2 times 3. Then we're going to distribute the 2 to the 4, and that becomes 2 times 4. We're going to add these together to get our sum. So 2 times 3 is 6. And 2 times 4 is 8. We add these together and the answer is 14. I accidentally put the wrong answer here. This should be 14. I multiplied 6 times 8 and put 48. So the answer really is 14 to the math problem 2 times the quantity 3 plus 4. Distributive property is when we put together addition and multiplication. We work with those 2 operations together. There is no distributive property well, there is. We'll learn that later on in middle school, talking about the distributive property more, because you'll use that quite a bit in algebra. So let's do a little review cap here and some little ways to remember these properties. Commutative property has to do with order not mattering. The associative property has to do with grouping not mattering. Identity is no change at all. Inverse is doing the opposite, taking its opposite. And distribute is when we connect addition to multiplication. And these are the number properties we'll work with this school year.